Hey everybody, let's look at a couple of examples for systems of equations in two variables. So solve the system, and I'm going to solve it the different ways: graphing, substitution, and elimination. So first off, we'll start with substitution. So I'm going to take this and I'm going to substitute. And I'll go ahead and I'll label equation 1, equation 2. So for substitution, I'm going to have, and what I need to do is I'm going to rewrite this and solve for a variable. I'm going to have x equals 2y plus 1. I'll rewrite equation 1, and then I'll leave equation 2 as it is. So I've isolated a variable in equation 1. So I know the value of x is this, so I'm going to take this value and I'm going to plug it into equation 2. So I have 3 times 2y plus 1 equals 6y plus 3. And now I need to solve. 6y plus 3 equals 6y plus 3. Alright, that should automatically draw your attention. Once I eliminate everything, what I'm left with is simply y equals y. This is a true statement. Y equals y. If it is a true statement, and I'm going to abbreviate here, I'm going to say infinitely many solutions. That's what I got from substitution. I couldn't go beyond that. Once I have y equals y, then that's where you know, okay, or it could be a number, it could be 2 equals 2, but as long as it's a true statement. Well, let's try elimination. So with elimination, we'll keep it the same way since I already have my stuff. Well, no, I'll rewrite it. I'll rewrite it to where I'll put it in your standard form, where it's ax plus by equals c. So what I'll have here, let's say I have x minus 2y. This will help us visualize also. And that is 3x minus 6y equals 3. Well, once I've rewritten it like this, I can look at this and I can say, let me get these written down. Equation 1 and equation 2 written there. I can look at this now and I can see that there's a dependency. I can see I can get equation 2 from equation 1 by multiplying equation 1 by 3. Or I could say I could get equation 1 from equation 2 by dividing everything by 3 or multiplying through by 1/3. So there's the dependency there. So, but I'm going to go ahead and I will do elimination. So I'm going to take, how I'm going to work it is I'm going to take equation 1 and I'm going to multiply it by -3. So -3 times equation 1. I end up with a -3x plus 6y equals a -3. And here's equation 2. Whoops, I wrote an x up there. Whenever I add these together, those cancel out, those cancel out, those cancel out. I'm left with 0 equals 0. Again, true statement. And I have infinitely many solutions. So whenever you end up with infinitely many solutions, your work is cut in half. And it's nice to be able to recognize it. You can look up here and how the equation's originally written. It's tough to be able to see if there's that dependency. And I will not advise you to turn around and make sure that you rewrite all your equations, do everything unless you choose to, so that way you see it right off the bat, because it's very quick to see that there is just a true statement just by performing one step. What I'd also like to do is let's look at it graphically. And here's the graph. I have 2y equals x minus 1 in red, and then I have 3x equals 6y plus 3 in blue, and the blue will take over the red, but all the dots on there are showing you all the points where they meet. That's what Desmos is showing. They're both the same line. Infinitely many solutions. All right, how about another example? And if you're critically thinking and reasoning, you should already be able to say, I bet you I know what this example is going to deal with. So, pause the video and attempt to solve it using substitution and elimination. We will also view this graphically after we solved with substitution and elimination. Alright, so using substitution, I need to do some rewriting. I need to isolate a variable. I'll isolate y since it's all by itself. So I have 4x minus 2y equals 3, and that's equation 1 still. And then let's solve for y. So I would have y, and that would be 2x minus 4, because I got to get rid of that negative sign with the y. And that's equation 2. So I'm going to take this value here and I'm going to plug it in for y. So I have 4x minus 2 times 2x minus 4, and that's going to equal 3. 4x minus 4x plus 8 equals 3, and I end up with 8 equals 3. And that is an untrue statement. Untrue statement. No solution. Untrue statements give you no solution. So there's no solution. Again, this is quick. You do one of the steps and then you find out that it doesn't work. And then let's look at elimination. And for this, I'll multiply through equation 2 by a negative 2. So what I'm going to say is, I'll multiply this by equation 2 by a negative 2. And I'll just go ahead and write it out. 4x minus 2y equals 3. And then that becomes a negative 4x plus 2y equals a negative 8. And whenever I add those together, all my variables cancel. I'm left with 0 equals a negative 5. Again, untrue. No solution. No solution. That means they're parallel lines. And let me point this out, is that if I turn around and I rewrote these, so let's see, I should have the same slope in different y-intercepts. So y, that will be a negative, y equals 2x minus 3 halves. And for this one, I already did this one, 2x minus 4. Same slopes, but different y-intercepts. That means they have the same slope, but they're intersecting the y-axis at a different spot. So, Desmos, here are my two equations. And they are parallel lines. So all three methods show you the same thing. Alright guys, so you could see all three different methods, and you get to see how it works whenever you end up with infinitely many solutions as your answer and no solutions as your answer. You can use any of the methods. I will tell you that as you advance up in math, unless it's clearly obvious, I do not use graphing and I do not use substitution. I use elimination. That's just the way my brain works. Some of your homework problems, it's going to be very easy to just use substitution. The graphing method, again, the scale of it could be to where it's so hard to graph you wouldn't be able to see the intersection. So make sure that you know how to rely upon substitution and elimination. Watch your publisher's videos, critically think and structure your homework, and good luck on your homework.